What's up, Internet? It's your close personal friend, Jesse Stiles. Today we are going to be looking at using an Intel depth sensing camera to render ourselves as a floating hologram thing that we can superimpose on top of other video sources. Because this is a depth camera, it's going to be creating a sort of 3D model of this image, and we can do 3D manipulations of that. We're going to be doing this using free open source software tools. So the only thing you would have to pay for in order to make this run is the sensor itself, which is a relatively affordable device. The actual software we're going to use to view the camera is going to be code written in Python, but you don't have to do any coding to execute this. You can just use the code that I provide. I am going to first of all outline my motivation for this project. Then I will show you how to do this on a Windows computer, then a Mac computer, which is significantly more painful, but it does work. And then we'll look at the actual Python code that we're using to display this. Again, you can just use the Python code that I provide, but if you want to, you could manipulate this to do different things. So I am an electronic musician and art maker, and I teach those subjects at Carnegie Mellon University. I'm recording this in late August 2020, which means I'm in the process of getting ready to do a whole bunch of remote teaching. I specifically teach a lot of computer-based stuff, so I'm going to be recording a lot of videos for my students where I'm demonstrating how to do different kinds of things on a computer. And when I do this, I want to be in these videos. I don't want it to just be a computer screen. I'd like to have some presence in these videos. That being said, I don't want to take up the entire screen. I want to sort of minimize that visual presence that I'm superimposing on my instructions. I also don't necessarily want my house to be part of these videos because that's distracting and weird. So traditionally, if we wanted to remove the background from our video, we would use a green screen. I don't have a green screen. I don't have a place in my house to set up a green screen. I do have this tiny Intel depth sensing camera, so I can use that to remove the background from my images using depth rather than some specific color. As you can see, this is also creating an image that has a kind of glitchy 3D quality. So for what I'm doing, this is quite a good look because what I'm teaching is all about using digital tools in experimental ways. For what you're doing, I don't know, maybe this aesthetic would be too distracting, but for me, it's freaking cool. So, all right, let's move on to looking at how to set up this sensor to be used on a couple different computing platforms, starting with Windows and then moving on to Mac computers. Okay, getting this device working on a Windows machine is fairly painless. We are going to use the librealsense software libraries that are provided by Intel. You can find the link to this in the description of this video, or just Google librealsense, L-I-B, RealSense, and you'll find the GitHub repository. And the first thing we're going to do is just download the ready-made viewer application. So we're going to go to download and install and go to latest releases. And let's download the RealSense viewer.exe. We get some messages here that I think we can ignore. What do you want? There's some errors, whatever. Let's turn on some of these toggles over here. And cool, we can see some like 3D nonsense. There's actually some tabs here. Here's our 2D nonsense and then the 3D nonsense. You can texturize it with the actual color image, and here you're getting, this is kind of like what I'm going for a little bit. It's sort of a point cloud representation of what we have in front of the sensor, and we can look at it from different angles. And ultimately, we're going to try to remove the background to make this work more like a green screen. So we're going to set a kind of cutoff in terms of distance, and anything beyond that distance is not going to be picked up by the code that we use. All right, so that's a good proof of concept that we're able to open up this sensor on this computer. The next thing we're going to do is try to access it using the Python libraries that are provided in this GitHub repository. To get the Python libraries, we're going to clone this GitHub repository. If you don't know what those words mean, don't worry about it. It's not going to be too painful, but we are going to have to do some stuff in the command prompt. So let's do Windows X, and then we can get a command prompt going from there. All right. So we're going to clone this GitHub repository by saying git clone, and then back here we can get the link to the repo from that code button, and I'm just going to paste that, and this is downloading a copy of that repository, which apparently it's going to take a couple minutes, so you can go get yourself a coffee. If you're not familiar with cloning repositories from a command prompt like this, one thing you might be wondering is, like, where are these files actually going to on my computer? It's going into this folder right here, which is C users and then your username. You're going to have a new folder there named librealsense. So, let's see if we can find it. I'm bad at using Windows computers, by the way. Let's go to this PC, and here's our hard drive. Here's our users. That is me. And this is the folder we're creating, librealsense. Apparently it's empty until this is fully cloned. Okay, cloning is complete, and there is going to be a folder in here called wrappers. That's going to have our Python stuff in the Python folder, and there's some examples that we can try to run from this examples folder. So first of all, let's make sure we have Python 3 installed on this computer. We can say Python version, and I've got some version of Python 3, so I'm good to go. If you don't have Python on your machine, go get it. Just Google how to install Python on my Windows computer, and then you'll be able to run these Python commands. So let's just see what happens if we try to run one of these examples. I'm going to say Python, and we can just drag in this Python file, and the command prompt is going to give us the full path that goes to where that file is, and we can hit enter. And we can see, all right, we've got some Python libraries that we need to import. So let's try to install this missing library using pip. Okay, we have successfully pipped our RealSense 2. I'm getting this warning that my pip is not current, but whatever. Let's try the same command we did before by hitting the up button until we see it reappear. Okay, and we did not get an error that the library was missing, so that's good. I did get an error that there's no frickin' device connected. Okay, I just plugged in the sensor to this computer, so third time's the charm, maybe. Hey, sweet. Okay, that's like me, and I'm ASCII art. So thanks for the tutorial, friends. Can I hit the escape key? Nope. How about Control C? All right, Control C canceled that. Control C will cancel lots of things when we're in our command prompts. Okay, so these different Python examples are going to require some different libraries depending on which ones you try. These ones that say OpenCV are going to be using OpenCV, which is not installed on this machine, so I'm going to skip those, but you could try them. You'll just need to install OpenCV and do a little research about how that works. This is the one I really want to try, the point cloud viewer. This is going to be what I'm basing my finished Python code upon. So let's see if it'll run right out of the box. I'm going to say Python and then the Piglet point cloud viewer. And apparently I'm missing Piglet, so let's pip install Piglet, collecting, installing. Okay, it's installed. My computer's still angry about its old pip, but whatever. Let's try to run it again. And this might give us an error. Yes. Okay. In the code, there is like some outdated stuff, and we're getting this error that has to do with the clock display. So to fix this, I'm going to open this code in my text editor of choice, which is this one, Atom. And we're going to hunt down this error and just get rid of it. Here's the code. So if we search the code for clock, that's just a comment. That's a comment, but here's where the problems come. There's going to be this command that it tries to run called FPS display. So let's just comment out that whole block of code by selecting it and then doing Control/. And then let's find the other place in the code where it actually tries to do this. FPS display, and let's comment that out. And let's just save it. And then try to run it again. Sick. Okay, so here is our point cloud viewer, and this is running on our Python code. So this is already pretty similar to the finished product that I want. I just want to be able to basically get rid of the background and then get rid of these like computer graphic things that are rendered on top of the point cloud representation of me. So this Windows computer is now ready to run. It can open the sensor and we can access the sensor using Python. So you can skip ahead to running the Python code if you want. The next thing I'm going to do in this tutorial is do the same thing on a Mac. And you know, in general, I find Mac computers easier to use than Windows computers, but this is one area in which Mac computers lose super hard. Doing this on a Mac is going to be way more of a pain in the ass than what we just did to get it running on this Windows computer. So let's go over to a Mac computer and watch me suffer. Okay, so now let's get this device working on a Mac computer. We're going to need Homebrew to install some libraries. We're going to check to see if we have Homebrew by doing brew update. If we do have Homebrew, it's just going to update it. If you don't have Homebrew, you can follow the link to install it. We're going to check that we have a contemporary version of Python, which we do. If you do not, you can follow the links for installing and linking the latest version of Python. And then we are going to end up using pip to install Python dependencies. You don't automatically have pip, so check if you have pip. If you do not have pip, again, follow the link. All right, so we have Homebrew. We can use Homebrew to install the librealsense library. So this will give us the drivers that we need to open the device and some examples for testing it. And this might take a few minutes. I don't remember. It's downloading things. Hey, okay, that was actually pretty fast. And so it tells us that there's now going to be some new stuff at this location on our computer. So let's go look in there. You can go to your Finder and we'll say go to folder. And if we say -USR, it takes us to this invisible library. And then you can go into local cellar. This is the cellar of your frickin' computer, and this is a new folder called librealsense. And where is the stuff? Nope, here. So if we go into the bin folder, these are some examples we can run to test the device on this Mac computer. So I'm going to plug in the device and then test one of these out. Okay, the Intel device is now connected to this Mac computer, so I'm going to try to run one of these examples by just opening it from the Finder. We see the same software that we saw in Windows loading up. There's some welcome stuff, and let's try to turn on the device. Hurrah! Okay, so we're actually getting some data out of this device on a Mac computer. That was not too bad. Sweet. Let's quit this. And the next thing we're going to do is we have to compile the Python objects from scratch using the source code. You can't just pip these Python objects onto a Mac computer, unfortunately. So the first thing we're going to do is clone the librealsense GitHub repository onto this computer. So let me copy the code that does this. Here it is. We're going to git clone and then the link to the repository. And in my home directory, there's a new folder called librealsense, and once our cloning is complete, we should see the things. Behold, the things. Okay. Next steps, we're going to actually skip these. I'm doing this a little bit out of order. We're going to use brew to install some dependencies that we need. So we're going to install cmake, libusp, and pkgconfig. All right, and then we're going to use brew again to install some Vulkan stuff. Okay, we got the Vulkan, and I just want to say, you know, I grew up in Boston, and in Boston, we did not have regular sized bowling balls and bowling pins. We had what I think most people call duck pin bowling, but we just called it bowling. I had no idea that regular bowling balls existed in the world, and I didn't find out about them until I went to college. And when I did, I was horrified. It was like a nightmare where like you think you understand how objects work and what size they are, and then some Alice in Wonderland stuff happens to you. It was very traumatizing, and I don't feel like I'm very good at bowling because of this misleading experience I had as a young person in Boston. So I guess this is mostly a message to children in Boston. I want you to know that when you grow up and get out in the world to other cities, you're going to find different kinds of bowling balls. They're not going to be what you're used to, so be ready for that. All right, we've installed Vulkan, and let's now do some stuff inside our newly downloaded librealsense folder. So in our terminal, we are currently in our home directory. You can type ls, and these are the different things in your home directory. The cd command will move us into a different folder. So we're going to move inside the librealsense folder. And here's the stuff that's inside the librealsense folder. We can make a new directory called build with this command, mkdir build, and then we can move inside of that. So here you can actually see the build folder that we just made. Okay. Inside of the build folder, we are going to run a cmake command that'll get us ready to compile these objects. To do this, we need to know the path to our Python executable, and we're going to find that by going into Python. So we're going to say Python. Now we're in Python. Inside of Python, I'm going to import the sys module, and then I'm going to use it to print the sys.executable, and that's the path to Python on this machine, and I can exit out of Python by doing exit. Sweet. All right, so here is the command we want to run. It is cmake blah blah blah, and then we're going to fill in the blank here with the path to our Python executable. And in the build folder, you can see we're now generating all this stuff from which we will be able to compile our Python objects using this next command, make J4. The -J and then a number is going to speed up the process by using more processors. This laptop, how many processors do we actually have? Oh, okay. That many. All right, so if we say J4, it's going to use 4 processors. And this will make it go a lot faster, but it's still going to take a while. So let's watch more bowling. Okay, that's done. Let's look at the next step. We did the make J4, so now we're going to do sudo make install to install the newly made things. And sudo is our super user, so we need to put in the password. To the computer, and it installs. Okay, so looking in our build folder, there is a folder called wrappers and the Python folder, and it has these SO files, and this is going to be the Python objects that we're using in order to use the RealSense sensor in Python. So the easiest way to do this is to just have these .so files in the same directory as the Python script that you're executing. There's more elegant ways to do this, but this is like a simple way to do it. So let's try putting a Python script in that folder with the .so objects. I'll go back into my librealsense folder, and in the root directory of librealsense, we've got our wrappers, Python, and there's an examples folder here. So let's copy this tutorial script into there, and let's also copy this piglet point viewer. We'll try both of those. So in our terminal, oops, we're going to say Python, and then if we drag the Python script that we want to run onto the terminal, it'll give us the full path to that file. So let's try to run it. Enter. Oh, look at that. Let's connect the device first. So let's unplug it from that machine and plug it into our Mac computer. Okay. So we're going to say Python, and then we'll just drag in the script we want to run and hit enter. There's a warning. Okay, we get a segmentation fault when we try to run this demo. Let's try to run, oh yeah, Python quit. And let's try to run the other one just for funsies. We do need to pip a few dependencies. So we're going to pip install piglet, which is relatively quick. And I know that it also needs numpy, so let's pip install numpy. And then we can hit the up key a few times until we find the previous command to try to run the piglet point cloud viewer again, this time with the dependencies. This also gives us an error. So let's try turning it off and then turning it on again. I'm just going to restart this frickin' computer. Okay, so we've got our compiled Python SO things in here. We've got a couple Python scripts. We've used pip to install piglet and numpy, which we need both of those to run the piglet example. So let's try again to use Python to run this script. Okay, and we're getting this error that we saw if you watched the section on doing this in Windows, that we're missing this attribute clock display. So let's, like we did before, edit this Python script to make it work. I'm going to find the FPS displayer that has this borked command. Let's just comment that whole block out, and then we'll comment out this line that invokes it. Let's save it and close it. Okay, cool. And now this Python script works. Yeah, if you get these errors when you're trying to run your Python script, I would suggest just try restarting the machine. That might be helpful. You could try running the examples again that are installed by Homebrew in your seller as a sanity check. You could restart and run them. But So I don't know exactly what's producing those errors sometimes, but just try turning it off and then turning it on again. Okay, so this is great. We've got the device on the Mac. We're able to get data out of it, and we are able to use the Python libraries to access this sensor. So let's move on now to modifying this Python code to do what we want it to do. And this will apply to Mac or Windows. As long as you have the device working on your computer and you have the Python libraries working, we're just going to be looking at Python code now. Again, you don't need to know how to program in Python to make this work. You could just use the example code that I'm going to be providing. But if you want to, if you do know Python, you can look at this and then modify it to do different things. All right, here I am on a Mac computer that is all configured to access the depth sensor and use Python to get the data. I've made a new project folder where I've got the SO files that we compiled, and I've got this Python script that I'm going to use as my starting place. If you're on a Windows computer, you wouldn't need to have these SO files in the same directory, but I'm on this Mac. So let's just test that this works. And there it is. So I'm going to now just do some modifications on this code to get rid of the computer graphics stuff that's sort of superimposed on the point cloud. And then I also want to be able to get rid of this background. I'll just remove everything that's beyond a certain distance from the sensor. So let's open this code in Atom. And if we scroll through it, we'll see that there are some functions here: axes, frustum, and grid. These are what are drawing those computer graphic things that we want to get rid of. So we could just find the places inside this code where those get invoked and comment them out by selecting the line and doing command /. So let's comment out all the axes. That's all of them. And we can comment out wherever the frustum gets invoked, which is just this one place here. And let's comment out anywhere that the grid gets invoked, which I think is just this one place here. And I'm going to do a save as, and I'll call this my Piglet point cloud viewer, and I'm going to put it in the same directory. Back in our terminal, we can do Control-C to cancel the running Python thing. And then let's try to run our new version of this Python script. And there's an error on line 319. What did we do? Okay. This was like an if statement, and then there was a thing you do if the if statement is true. So let's actually comment out the entire if statement starting on the line before. And we'll try again. Yeah, cool. So there's just the point cloud with none of the computer graphics stuff superimposed on it. So what I want to do next is get rid of everything that is beyond a certain distance from the depth sensor, so that I could kind of use this as like a green screen device to remove the background when I'm filming things. So there are different ways that this could be done. This is a depth sensing camera, So it's giving us basically two streams of data. One is the color information, which it's getting from a sort of normal color camera, and the other is the depth data. So we could remove all the stuff in the background using some math on the depth data, where we could just sort of like say if the depth is beyond a certain value, do not render this point cloud. That would be maybe the smart person way to do this. There is an easier way to do it with these Intel sensors. They have an advanced mode, and in the advanced mode, you can clamp out certain distances. You can set a maximum distance, and beyond that, it just won't provide any data. So that's actually a little easier, and that is what we're going to do. So one of the Python examples that is provided shows some of the things you can do with the advanced settings on certain Intel depth sensors. So I have copy pasted some of that code that starts advanced mode, and then I've added a few lines down here that gets the depth table and then clamps it within a certain range. So I've set a maximum value here of 1.3 meters and a minimum value. So I'm going to copy this block of code and paste it into my main Python script right after I import these libraries. And let's save it, go back to the terminal and run the new version of it. Hooray! Okay, so now all the stuff beyond 1.3 meters is just not getting picked up by this device at all, and we didn't have to do any fancy math. It's just gone. We could, if we wanted to play with different values, make this a larger maximum. Let's cancel the running Python script and run it again. And you see the background came back because my maximum value went up. So that's basically it. That's like, this gives us a very simple rendering of the point cloud. We can zoom in and move it using the mouse. There's a few other ways we can modify it that are described in the start of the code here. You can play around with different decimation values. You can toggle point scaling. You can toggle colorization options. And we can also now take this image and superimpose it very easily on other video sources because it's just hovering over a completely black background. So it'd be very easy to like chroma key this onto other sources. So let's look at just a simple example of doing that using OBS so that we could record a video of us demonstrating something on the computer with this 3D image superimposed upon it. Okay, so a quick demonstration of recording using the output of this Python script as a video source. We can start our Python script in terminal and we get our window. When you look at the source code, you can see there are some different kind of visual options that you can change by typing keys. You can also zoom in and pan around with your mouse. So I'll zoom it the way I want. And then if you wanted to like adjust these other things, you've got stuff like your decimation values. You can colorize it with different sources. So let's just leave it like that. And we're going to go into OBS, which is a free open source video streaming recording program, which is cross-platform. Currently, it has two sources. It has my microphone, and it's using the entire computer display as a video source, which is creating this awesome video feedback right now. So I want to put on top of this the output of this Python window. So in OBS, we're just going to add another source, which is a window capture, and it's going to be the output of our Python program, this one, Python RealSense. And it has the black background, which we can strip out by adding a key effect in OBS. So we'll right click on it and go to filters. And we're going to add an effect filter, which is a color key. And you can choose a custom color, which we're just going to make black. And there's some different knobs here, so let's just get it looking decent. That seems fine. Sure. Okay, and then we can position this on top of our image. And we should now be recording with our point cloud image superimposed on the computer screen. One thing to point out is that you don't want to minimize this window or it will disappear from OBS as a source. So you can just like tuck it away somewhere or put it on a second monitor, but don't minimize it. It needs to be actually running somewhere. Word. Okay, thank you for joining us. I hope you enjoy being hologram. Peace.